What if you can't die? Not because you're immortal, but because every time you should have died you didn't. Every car accident you barely avoided, every illness you survived, every moment where things could have gone wrong but didn't. What if those weren't luck? What if in countless other universes you did die? What if you're only here because you can only experience timelines where you survive? What if you've already died 1,000 times and you just don't remember? If these explorations intrigue you, a like or subscribe helps, but let's continue. Think back to your closest call, the moment where things almost went wrong, the car that swerved at the last second, the illness that could have been worse, the split-second decision that saved you. You remember it as luck, a near miss, a bullet dodged. But what if it wasn't? What if in another universe, a universe just as real as this one, you didn't survive? What if the car didn't swerve? What if the illness was terminal? What if that version of you is dead right now? And here's the disturbing part, you'd never know, because you can't experience the timelines where you die. You can only be conscious in the timelines where you continue to exist. Death, from your perspective, is impossible to experience. You'll never feel yourself stop. You'll never know the moment it ends. You'll just keep going, always waking up, always surviving, always in the timeline where somehow, impossibly, you're still here. This is quantum immortality, and it's not mysticism. It's a direct logical consequence of quantum mechanics' most rigorous interpretation, the many worlds interpretation. If that interpretation is correct, then right now, as you listen to this, you might be living in one of the last remaining branches where you're still alive. Think about it statistically. You've been alive for years, decades maybe. Every second of every day there are ways you could die. Aneurysms, random accidents, cosmic rays, flipping the wrong bit in your DNA, lightning strikes, structural failures, heart defects you don't know you have, the probability that you survive all of them every single day for your entire life. It's vanishingly small, and yet here you are. Not because you're special, not because you're protected, but because you can only observe the timeline where you survived. All the other versions of you, the ones who didn't make it, they're gone, silent, experiencing nothing. But you keep experiencing, keep existing, keep finding yourself alive against increasingly impossible odds. This isn't comforting. This is horror masquerading as survival, because if quantum immortality is real, then your continued existence isn't luck. It's inevitability. You're not dodging death. You're just never able to experience it, stuck in an ever-narrowing branch of reality where somehow, impossibly, you keep surviving. And the question you can't escape: how many times have you already died? How many versions of you are gone? How many timelines ended while you slept, while you crossed the street, while you took that flight? You'll never know. You can't know. You can only be here, alive, wondering. Let's understand why. In 1957, a graduate student named Hugh Everett proposed something so radical that most physicists dismissed it immediately. He said, what if the universe never chooses? What if every quantum possibility that could happen does happen? Not in some abstract mathematical sense. Actually happens. In real, physical universes that branch off from ours every time a quantum event resolves. This is the many worlds interpretation of quantum mechanics, and if it's correct, reality is far stranger than we ever imagined. Here's the problem Everett was trying to solve. Quantum mechanics says particles exist in superposition, multiple states simultaneously, until they're measured. An electron is spinning both up and down at the same time. A photon goes through both slits at once. The math works perfectly. The predictions are flawless. But then you measure it. You look. And suddenly the superposition collapses. The particle chooses one state. The wave function falls into a single outcome. Why? What counts as measurement? What makes the universe decide? Nobody knew. It's called the measurement problem, and it's haunted quantum mechanics for a century. Everett's answer was elegant and terrifying. Nothing decides. The universe doesn't collapse into one outcome, it splits into every outcome. When you measure that electron, it doesn't choose spin up or spin down. Both happen. The universe branches. In one branch, you measure spin up. In another branch, equally real, equally physical, you measure spin down. Both versions of you exist. Both are convinced they got a single, definite result. But you didn't. Reality did both. Think about what this means. Every quantum event, and there are trillions happening every microsecond, creates a split, a branching. The universe duplicates itself, diverges, multiplies. Right now, as you listen to this, quantum events in your brain are resolving. Particles decaying, electrons jumping states. Each one a branch point, each one creating new universes. In some branches you keep listening, in others you pause, in others still a cosmic ray hits your neurons differently and you have a slightly different thought. All of it real, all of it happening. The mathematics demands it. If superposition is real before measurement, and nothing special happens during measurement except decoherence, the entanglement of the quantum system with its environment, then superposition never ends. It just expands to include you, the observer. You enter superposition too. You split. And here's the critical part for quantum immortality. This splitting is continuous, relentless. Reality branches at every quantum decision point. Most branches are nearly identical. Some diverge wildly, and in some branches you die. Maybe a quantum fluctuation triggers a fatal heart arrhythmia. Maybe a cosmic ray causes a neuron to misfire catastrophically. Maybe a random quantum event weakens a blood vessel wall just enough. In those branches, you're gone. But in others, perhaps fewer, perhaps increasingly rare, you survive. The quantum coin flip goes your way. The fluctuation doesn't happen. The cosmic ray misses. And here's the twist Everett probably didn't fully appreciate. You can only experience the branches where you survive. Death ends your subjective experience in that branch, but consciousness continues in the others. Your point of view, your awareness, your sense of being you, it can only exist in timelines where you're alive, which means from your perspective, the probability of continued existence is always 100%, not because you're lucky, but because the alternatives are unobservable to you. Every moment you survive is another branch point, another split. And in your subjective experience, you always find yourself in the surviving branch. Always. You can't experience anything else. The universe splits. Most versions of you die. But you, the experiencing you, the conscious you keep going. Because you have to. Because there's nowhere else for your consciousness to be. This isn't immortality. It's something stranger. It's the impossibility of experiencing your own non-existence. And it has a name. Quantum immortality. Let's see what happens when we take this seriously. In 1997, physicist Max Tegmark proposed something disturbing. Not an experiment you'd ever actually do, but a thought experiment that reveals the full horror of quantum immortality. He called it quantum suicide. Here's the setup. You have a gun. But it's not an ordinary gun. It's connected to a quantum device, something that measures the spin of a particle in superposition. If the particle is spin up, the gun fires. If it's spin down, it clicks empty. 50-50 chance. Pure quantum randomness. You point it at your head and pull the trigger. What happens? According to standard quantum mechanics, the universe splits. In one branch, the particle is spin up. The gun fires. You die instantly. In the other branch, spin down. The gun clicks. You survive. From the outside, from anyone watching, there's a 50% chance you die. They might see your body. They might attend your funeral. In half of all branches, you're gone. But from your perspective, you only hear the click. You pull the trigger again. The universe splits again. In one branch, you die. In the other, you survive. But you can only experience the branch where you're alive. Another click. Again. Click. Again. Click. 10 times. 20 times, 100 times, every single time you hear the click, every single time you survive, because you cannot experience the alternative. In the branches where the gun fired, there's no you to experience anything. The outside observers see something very different. After the first trigger pull, half of them see you dead. After the second, 3/4 see you dead. After 10 pulls, 99.9% of observers see your corpse. After 100 pulls, your survival is so statistically impossible that it defies explanation. But you experience 100 clicks, 100 survivals, because that's the only thing you can experience. This is the asymmetry at the heart of quantum immortality. What you experience and what others experience diverge completely. To everyone else, you're almost certainly dead. Your survival is a statistical miracle, a 1 in a trillion fluke. But to you, your survival is absolute certainty, 100%. Because the branches where you died are inaccessible to your consciousness. Tegmark wasn't suggesting anyone actually do this. The thought experiment is a proof of concept. It demonstrates that if many worlds is correct, there is always a branch where you survive, no matter how improbable. And here's where it gets darker. This isn't just about quantum guns. This is about every moment of your life. Your heart depends on quantum processes, sodium and potassium ions crossing cell membranes, electrical impulses in neurons. Any of these could fail due to quantum fluctuation. In some branches, they do. Your heart stops. You die. But in others, the fluctuation doesn't happen. You keep going. You cross the street. In some branches, a distracted driver doesn't see you. Impact. Death. In others, they break just in time. You survive. You're alive right now because in this branch, every quantum event that could have killed you didn't. But in countless other branches, perhaps the vast majority, you're already gone. The quantum suicide thought experiment isn't just theoretical. It's what's happening to you right now. Every second, you're playing quantum Russian roulette with existence itself. And from your perspective, you always survive. Not because you're lucky, but because you can't experience the alternative. The gun keeps clicking. The car keeps missing. The heart keeps beating. And you keep finding yourself alive in increasingly improbable timelines, wondering why you're so lucky. You're not lucky. You just can't be anywhere else. Let's talk about why that matters. There's a principle in cosmology that sounds obvious until you think about it too hard. It's called the Anthropic principle, and it goes like this. Of course the universe is compatible with our existence. If it weren't, we wouldn't be here to observe it. Obvious, right? But the implications are staggering. The universe's fundamental constants, gravity, the strong nuclear force, the cosmological constant, they're fine-tuned to a degree that seems impossible. Change any of them by a fraction of a percent and stars don't form. Chemistry doesn't work, life never begins. Why are we in a universe where these constants have exactly the right values? The Anthropic principle says, because we can only exist in a universe where they do. We're not observing a random universe. We're observing the one that permits observers. It's a selection effect. You can't find yourself in a universe incompatible with your existence. Now apply this logic to quantum immortality. You can't experience timelines where you don't exist. You can only experience timelines where you're alive. So of course you find yourself alive. Of course you've survived every close call. Of course you're still here. Not because you're special. Not because the universe protects you. But because the branches where you died are unobservable to you. They exist. Countless versions of you are gone. But you can't be in those branches. By definition, you can only be in the branches where you survived. Your continued existence is the ultimate selection bias. Think about a lottery. 1 million people play. One person wins. From the outside, the odds were 1 in 1 million. But from the winner's perspective, they have a winning ticket. Their probability of winning retroactively is 100%, because they can only observe the outcome where they won. You are that lottery winner. Except the lottery is existence itself, and it runs every second of every day. Every quantum event that could kill you is a lottery you can only experience winning. The cosmic ray that could trigger fatal cancer. In most branches it does. In yours it missed. The blood clot that could cause a stroke. In most branches it formed. In yours it didn't. You keep winning. Not because you're lucky, but because you can't observe the alternative. This is anthropic reasoning applied to individual existence. Just as we can only observe a universe compatible with observers, you can only observe a timeline compatible with you being alive to observe it. And here's the disturbing extension. As you age, your continued survival becomes more improbable. The number of ways you can die increases. Cellular degradation, organ failure, statistical inevitabilities. In most branches, you're already dead. The measure of your existence, the proportion of branches containing a living you, shrinks with every passing year. But from your perspective, that measure is always 100% because you're only experiencing the branches where you're still here, the improbable ones, the increasingly unlikely ones. You're not observing typical outcomes, you're observing survivorship-biased outcomes. Every moment you exist, you're in a more statistically unusual timeline than the moment before, and you'd never know. Because this is all you can experience, this timeline, this survival, this improbable continuation. The anthropic principle doesn't just explain why the universe permits life, it explains why you specifically are alive right now, not because it was likely, but because you can only observe the branches where it happened. You're not experiencing normal probability, you're experiencing conditional probability, probability conditioned on your continued existence. And that condition is absolute, unbreakable. You can only be where you are. You can only be alive. The dead branches might outnumber the living ones 1,000,000 to 1, 1,000,000,000 to 1, but you'll never experience those odds. You'll just keep waking up, keep surviving, keep being the version that made it. Because there's nowhere else you can be. Let's explore what that means for your subjective experience. From your perspective, the probability of your continued existence is always 100%. Read that again. Let it sit. Not 99%, not pretty likely. 100%. Absolute. Certain. Because you are only capable of experiencing moments where you exist. Death is not an experience you can have. It's the absence of experience, the end of observation, and you, by definition, cannot observe your own non-existence. This creates something philosophically horrifying, subjective immortality. Not immortality in the traditional sense. You're not invulnerable. You're not going to live forever in any single timeline. In most branches, you're already dead. But from your internal first-person perspective, from the only perspective you have access to, you never experience dying. You always wake up. Think about surgery, general anesthesia. You go under, consciousness stops, hours pass, then you wake up. But what if you didn't wake up? What if something went wrong? What if in some branches you died on that table? You'd never know, because you can only experience the branches where you woke up, where the surgery succeeded, where your heart kept beating. From your perspective, you always wake up from surgery. Always. Even if the odds were terrible, even if most versions of you didn't make it, you can only observe the survivals. This applies to sleep itself. Every night you lose consciousness. Your breathing could stop. Your heart could fail. An aneurysm could rupture. In some branches you don't wake up. Your family finds you in the morning. Gone. But you always wake up. Every single morning of your life. Because the mornings where you don't wake up are unobservable to you. Consciousness is a one-way street. You can enter it. You can never experience leaving it. And this creates a strange certainty. Not certainty about the external world. That remains probabilistic, uncertain, quantum. But certainty about your own subjective continuity. From your perspective, you will always experience the next moment, and the next, and the next. Not because it's physically guaranteed, but because the alternative is unobservable. You might be in a timeline where you're 90 years old, or 120, or 1,000. You don't know how long your subjective experience will continue because you can't observe the endpoint. You can only observe the continuation. Every breath you take is in a timeline where you're still breathing. Every heartbeat is in a timeline where your heart still beats. This isn't profound luck, it's tautological necessity. You can only observe the observations you're capable of making. But here's where it gets darker. If subjective immortality is real, then aging becomes a trap. Your body degrades, cells fail, organs weaken. In most timelines, this kills you, but in the timelines you experience it doesn't. You keep surviving. But in what state? You might find yourself in increasingly broken bodies, increasingly improbable medical survivals, barely alive, but alive. Because barely alive is still a state you can observe. Death is not. The horror isn't that you die. The horror is that you might not be able to die. That from your perspective, you're condemned to experience continuation, forever finding yourself in the surviving branch no matter how improbable, no matter how damaged, no matter how much you might want it to end. Subjective immortality isn't eternal youth. It's not paradise. It's the impossibility of experiencing cessation. You're not living forever. You're just never experiencing the alternative, and there's no escape. Because escape would require experiencing non-existence, which is definitionally impossible. You're conscious now. From your perspective, you always will be. Not because your consciousness is eternal, but because the moments where it isn't are inaccessible to you. This moment, and the next, and the next. Always the next. Always. Alive. Always experiencing. Let's confront just how many times you might have already died. Let's do the math. Not the precise math, that's impossible, but the shape of it. The statistics of your survival. You've been alive for how long? 20 years? 40? 60? Every second of every one of those years, quantum events were occurring in your body. Particles decaying, ions crossing membranes, electrons jumping states, trillions upon trillions of quantum events, most of them harmless, but some of them, a tiny fraction, could kill you. A cosmic ray hits a cell in your heart at just the wrong angle. A quantum fluctuation causes a neuron to misfire catastrophically. A random mutation triggers runaway cell division. A sodium channel fails to open, your heartbeat stutters, and you die. In most branches, one of these things happened. You're dead in most universes already. Not metaphorically, actually dead. Your body cold, your family grieving, your funeral held. In the vast majority of quantum branches that contain a version of you, that version is gone. The measure problem in many worlds asks, how do we count branches? How do we assign probability when everything happens? The math gets complicated, but the basic intuition is clear. Branches where you die outnumber branches where you survive. Think about a car accident. You're driving. A truck runs a red light. In some branches, you see it in time. Swerve. Survive. In others, you don't. Impact. Death. How many branches end in death versus survival? It depends on precise timing, exact speeds, quantum variations in your neural processing, the truck driver's reaction time, all subject to quantum uncertainty. Maybe it's 50-50, maybe it's 90-10. But it's never 100% survival across all branches, which means in some significant fraction of branches you died in that accident. Those versions of you are gone. But you, the observing you, you're in the branch that swerved, the branch that survived. Now multiply this across every near miss in your life, every illness, every risky decision, every moment where things could have gone catastrophically wrong. The branches where you died accumulate, stack up, compound. And it's not just dramatic near misses, it's mundane quantum probability. Right now, there's a non-zero probability that all the air molecules in the room spontaneously move to one corner, leaving you in vacuum. You'd suffocate in seconds. The probability is absurdly low, so low it's never happened in observable history, But it's not zero. In some branches, it happens. You're dead. There's a non-zero probability that quantum tunneling allows your electrons to spontaneously rearrange. Your molecular structure collapses. You cease to exist at the atomic level. Again, absurdly unlikely, but not impossible. In some branches, it happens. And here's the thing. As you age, the number of ways you can die increases. Your cells accumulate damage. Your DNA degrades. Your organs weaken. The probability of fatal failure rises. In more and more branches, you die. Heart attack, stroke, cancer, organ failure. The measure of your existence, the proportion of all branches containing a living you, shrinks, collapses, approaches zero. By the time you're 80, 90, 100 years old, you might exist in an infinitesimally small fraction of all possible branches. Most versions of you are long dead, decades dead. Some died in childhood, some in young adulthood, some recently. But you're still here, still observing, still conscious. Because you can only experience the branches where you survived. No matter how rare those branches become, you're living in an increasingly improbable timeline, a statistical outlier, a miraculous exception. Except it's not a miracle, it's selection bias. You're not lucky to be in the surviving branch. You can only be in the surviving branch. The dead branches are inaccessible, silent, unobservable. So yes, you're dead in most universes. Your gravestone exists in countless timelines. Your loved ones have mourned you in infinite branches, but not in this one, not in the one you're experiencing. And as the years pass, as your survival becomes more improbable, as the branches thin out, you keep finding yourself here, still alive, still observing, in timelines that are getting stranger. Let's talk about how strange they might become. Here's where quantum immortality stops being abstractly disturbing and starts being personally terrifying. If you can only experience timelines where you survive, and if those timelines become increasingly improbable as you age, then the timeline you're experiencing should start feeling off, strange, unusual, statistically weird. Because you're not in a typical timeline anymore. You're in an outlier, a low probability branch where, against mounting odds, you're still alive. And low probability branches don't just differ in your survival, they differ in everything. Think about it. The quantum events that keep you alive might require increasingly unusual circumstances, unlikely coincidences, improbable interventions, things that make you think, that was weird, that shouldn't have happened that way. Maybe you should have been in that car accident, but you left the house 2 minutes late because your shoelace broke. Quantum fluctuation in the material stress of the fabric. In most branches, it didn't break. You left on time. You were in the intersection when the truck ran the light. But in this branch, the one you're experiencing, the shoelace broke. You survived. As you accumulate these improbable survivals, your timeline diverges from the typical ones. It has to. The universe doesn't protect you specifically. It's just that the branches where you survive might require increasingly unusual configurations, and you might start noticing. Things feel different. Wrong somehow. Like reality isn't quite what it used to be. The Mandela effect might not be false memory. It might be evidence that you've shifted into a low probability branch, where details are different. Where the Berenstain Bears were spelled differently in the high probability branches where you died. But in this branch, the survival branch, the spelling was always different. You remember it wrong because you're remembering the high probability timeline, the normal one, the one where you're dead. People seem to be acting strangely. Politics feels increasingly surreal. Events that seem impossible keep happening. Not because the world has gone mad, but because you're in a timeline that's statistically unusual. A branch where unlikely things keep occurring, because unlikely things are required to keep you alive. You're experiencing reality from the tail end of the probability distribution, and it gets worse as you age. A 20-year-old in a low probability survival branch might not notice much difference. The divergence is small. But an 80-year-old, someone who should have died dozens of times by now, their timeline might be deeply strange. They might experience miraculous medical recoveries, impossible coincidences, events that defy reasonable explanation, not because they're special, but because they're in one of the few remaining branches where they're still alive, and those branches are weird by definition. This might explain why some elderly people report feeling like the world has changed, that things aren't what they used to be, that reality feels wrong. Maybe it does. Maybe they're experiencing a low probability branch, a timeline that diverged significantly from the norm precisely because divergence was required for their survival. You might already be in one of these strange branches. You might have been for years. How would you know? What does a normal timeline even feel like? You've only experienced this one, the one where you survived, the one that by definition is tailored to your continued existence. Every synchronicity, every impossible coincidence, every moment where you think, what are the odds? Maybe the odds are terrible. Maybe you're in a 1 in a billion timeline. But from your perspective, it's the only timeline, so it feels normal, even when it shouldn't. And here's the disturbing question you can't escape. Is your life unusually lucky? Or unusually unlucky? Are you experiencing improbable good, fortune, or improbable survival despite terrible circumstances? Maybe both. Maybe your timeline is weird in both directions. Chaotic, extreme. Because extreme timelines are what remain when the normal ones all ended in your death. You might be living in a reality that's already broken, and you'd never know, because this is all you can experience. Let's look at people who might already be there. Some people survive things they absolutely shouldn't. Their stories defy probability, shatter statistics, make you wonder, how? Maybe quantum immortality isn't just theory. Maybe we can see it in action. Let's start with Tsutomu Yamaguchi. On August 6, 1945, he was in Hiroshima on business. The atomic bomb detonated. He was less than 3 kilometers from ground zero. The blast ruptured his eardrums, burned his face and arms, and threw him into a ditch. He survived. He went home, to Nagasaki. On August 9th, 3 days later, the second atomic bomb fell. He was in an office building. Again, within the blast radius. Again, he survived. Tsutomu Yamaguchi is the only officially recognized survivor of both atomic bombings. He lived to be 93 years old. What are the odds? Not just of being in both cities at the exact wrong time, but of surviving both blasts, of walking away when hundreds of thousands died, of living a long life afterward. The probability is so low it approaches impossibility, and yet from Yamaguchi's perspective it happened. Because of course it did. Because he's the one observing, the one who can only experience the timeline where he survived. How many versions of Yamaguchi died in Hiroshima? How many more in Nagasaki? In how many branches does he exist at all past August 1945? Probably very few. But in this branch, the one he experienced, the one we read about, he survived both. Because he had to. Because his subjective experience could only continue in the branches where survival occurred. Then there's Frane Selak, a Croatian music teacher called the world's luckiest man. In 1962, his train derailed and plunged into a river. 17 people died. He survived with a broken arm and hypothermia. In 1963, his first plane flight, the door blew off mid-flight. He was thrown from the aircraft. 19 people died. He landed in a haystack. Minor injuries. In 1966, a bus he was on crashed into a river. 4 passengers drowned. He swam to shore. In 1970, his car caught fire while he was driving. He escaped seconds before the fuel tank exploded. In 1973, another car fire. This time, the flames came through the air vents. He lost most of his hair but survived. In 1995, he was hit by a bus in Zagreb. Minor injuries. In 1996, he was driving in the mountains. A truck came around a corner on the wrong side. He swerved, crashed through a guardrail, and his car plummeted 300 feet into a gorge. He was thrown from the vehicle before impact, caught a tree, and watched his car explode below him. 7 major incidents, each one potentially fatal, each one killing others who were there. But Selak walked away, every time. Then, in 2003, he won the lottery. $1 million. Luck or something else. From outside, Selak's survival looks miraculous, impossible. But from his perspective, he just kept experiencing the next moment and the next, because he couldn't experience the alternative. Maybe, in most branches, Friend Selak died in 1962 in that train crash. Maybe the branches where he survived are vanishingly rare, but he's in one, because he can only be in one. And maybe that branch, the improbable survival branch, is so unusual that other strange things happen there, like winning the lottery, because at that point, what's one more statistical anomaly? These aren't isolated cases. There are people who survive terminal cancer diagnoses, who walk away from plane crashes that kill everyone else, who should have died but didn't, for reasons no one can explain. Medical miracles, statistical impossibilities, people living in the extreme tail of the probability distribution. Are they lucky, or are they just experiencing quantum immortality in action, stuck in the increasingly improbable branches where their consciousness continues? You can't prove it either way. But the stories exist. The impossible survivors are real, and maybe you're one of them. Maybe you've already had your impossible survival, your inexplicable near miss, your moment where you should have died but didn't, and maybe that's not the last one. Let's talk about what happens when you keep surviving. If you can never experience your own death, when do you die? It's not a rhetorical question. It's a logical problem that quantum immortality creates, and the answer is deeply, profoundly disturbing. From your perspective, you might not die. Ever. Not because you're actually immortal. Your body will fail. It's failing right now. Cells degrading. DNA accumulating errors. Telomeres shortening. Entropy winning. In the vast majority of branches, you age, deteriorate, and die. But you can only experience the branches where you're still conscious, still observing, still alive. Which means from your subjective perspective, you asymptotically approach death, but never reach it. You get older, weaker, sicker. Your body breaks down in increasingly severe ways. But somehow, through increasingly improbable medical interventions, random chance, quantum fluctuations that keep critical systems functioning, you keep surviving, not thriving, surviving. This is the nightmare scenario quantum. Immortality doesn't advertise. You're not immortal in the sense of eternal youth. You're immortal in the sense that you can't experience cessation. You keep finding yourself alive in bodies that are failing, broken, barely functional. Imagine being 90. Your organs are shutting down. You should die. In most branches, you do. But in the branch you experience, a doctor tries one more experimental treatment. It works just barely enough. You survive another year, 100 years old. You shouldn't be conscious. Your brain is degraded. But quantum fluctuations keep just enough neurons firing. You're still here. Confused, in pain, but here. 110, 120. Sustained by medical intervention in increasingly improbable timelines. Because the branches where you die are unobservable. You can only experience the ones where some unlikely combination of factors keeps you breathing. This isn't life. This is trapped existence. And there's no escape. Because escape requires experiencing death, which you cannot do. Some physicists argue this is where quantum immortality breaks down. That consciousness requires a certain level of brain function, that there's a threshold below which you simply can't be conscious anymore, and below that threshold the branches merge. You die in all of them. But where's that threshold? How degraded can a brain be and still support subjective experience? We don't know. Patients in vegetative states might have some level of awareness we can't detect. Near-death experiences suggest consciousness persists in conditions we'd think impossible. Maybe the threshold is lower than we think. Maybe you can be conscious in states we consider worse than death. And if quantum immortality is real, you'll find yourself in those states. Because you have to. Because the alternative is unobservable. The horror isn't dying. The horror is not being able to die. From the outside, people see you deteriorate and eventually pass. They attend your funeral. They grieve. But from your perspective, you might just keep waking up in increasingly damaged bodies, in increasingly improbable medical scenarios, in timelines where somehow, impossibly, you're still conscious, forever. Or maybe not. Maybe consciousness does have a hard cutoff. Maybe there really is a point where you can't be aware anymore, and at that point, all branches converge. You die. You stop. But you'd never know. You'd never experience that transition. You just experience the moments leading up to it getting worse and worse until what? You don't know. You can't know. Some find this comforting, the idea that you never experience dying, that from your perspective there's always another moment, another breath, another experience. Others find it horrifying, the idea that you're trapped in existence, that you can't escape, that you might spend subjective eternity in failing bodies, in pain, in confusion, unable to die because dying isn't something you can experience. The optimistic interpretation, maybe you jump timelines. Maybe when your body fails catastrophically in one branch, your subjective experience shifts to a younger version in another branch. Maybe consciousness is fungible across versions of you. Maybe you wake up 10 years younger in a timeline that diverged earlier, but that's speculation. Hope, not physics. The physics just says you can only observe the moments where you're capable of observation, and those moments might never end. Let's talk about who's watching you die. Here's the loneliest implication of quantum immortality. Everyone you love dies, but you don't. From your perspective, you keep going. You attend their funerals, you grieve, you watch everyone around you age and pass away while you somehow impossibly keep surviving. Your parents die, your friends die, your children eventually die, and you're still here, still experiencing, still in the timeline where you haven't died yet. This isn't because you're special, it's because they can't take you with them. When your mother dies, the universe splits. In some branches, she survives a few more years. In others, she's gone. But her subjective experience continues only in the branches where she's alive, and your subjective experience continues only in the branches where you're alive. Those aren't necessarily the same branches. In her experience, maybe you die first. Maybe she attends your funeral. Maybe she grieves you. In her subjective timeline, you're gone, and she continues. Without you. But in your timeline, she's the one who died. You're the one left behind. Both are true. Both are real. You're just experiencing different branches of the quantum multiverse. And as you age, this asymmetry becomes more pronounced. You keep surviving in increasingly improbable timelines. But the people around you, they're dying in your timeline at normal rates, expected rates. You become the last one left, not because you're immortal and they're not, but because from your subjective perspective, you can never experience your own death, only theirs. This might explain the profound loneliness some very old people report, the sense that everyone they knew is gone, that they're living in a world that's moved on without them, that they shouldn't still be here. Maybe they're right. Maybe they're in one of the last remaining branches where they're alive. Everyone they loved is dead in their timeline, but alive and experiencing their own timelines where perhaps the old person died years ago. Grief, in this framework, is experiencing someone's branch death. They're gone from your timeline, but somewhere, in some other branch, they're still alive, still experiencing, still continuing. You just can't access that branch anymore. Your timelines have diverged. And they're grieving you in their timeline. This is the cruel mathematics of quantum immortality. Everyone experiences their own continuation. Everyone watches everyone else die. Everyone is simultaneously the survivor and the deceased. You can only walk your own path through the branching multiverse, and that path, by necessity, is a lonely one. because everyone else is walking their own paths, their own improbable survival timelines. You'll never die in your experience, but everyone you love will die in your experience, and in theirs, you're already gone. You're a ghost to them. They're ghosts to you. Everyone haunting everyone else's timelines, everyone continuing in branches the others can't access. The universe splits. We all go our separate ways, and we call it death. But it's not death. It's divergence. You're still out there. They're still out there. Just in different branches, different timelines, experiencing different versions of reality where different people survived, and you can never reach each other again. That's the real horror of quantum immortality. Not that you can't die, but that you have to watch everyone else die, over and over, while you keep going. Alone. Still conscious. Still here. Let's see if you're already living in an improbable timeline. Stop for a moment. Think about your life. Really think about it. How many close calls have you had? How many times did things almost go catastrophically wrong but didn't? The car that almost hit you. The illness you recovered from. The decision that could have ruined everything but somehow worked out. The moment where you thought, I shouldn't be alive right now. How many? Now ask yourself, is that normal? Are you statistically typical? Or are you living a charmed life, or a cursed one that you keep surviving? Here's a test, not a scientific one. There's no scientific test for this. But a thought experiment. If you were in a low probability survival timeline, what would that feel like? What would be the signs, maybe, improbable survivals, near misses you can't explain, moments where luck seemed to intervene impossibly, you walked away from something you shouldn't have, maybe, synchronicities, coincidences that feel too perfect, running into the right person at the right time, finding the exact thing you needed when you needed it, the universe seeming to conspire in your favor, or at least in favor of your survival, maybe a sense of unreality, feeling like things aren't quite right, like the world has changed, like you're living in a timeline that diverged from the normal one somewhere along the way. Do you experience these things? Here's the problem. Everyone does, to some degree. Human brains are pattern recognition machines. We notice coincidences and ignore the mundane. We remember near misses and forget uneventful days. We feel like we're special because we're experiencing our own lives from the inside. So you can't use subjective feelings as evidence. You can't trust your intuition here, but you also can't dismiss it entirely. Because if quantum immortality is real, some people are in extremely low probability timelines, and statistically it might be you. Think about your age. How old are you? How many years have you survived? Every year increases the likelihood that you should have died by now. Every year makes your continued survival more improbable. Are you older than average? Have you survived past the life expectancy for your demographic? Have you beaten diseases with low survival rates? Have you walked away from accidents that kill most people? If yes, you might be in a low probability branch. Or you might just be lucky. There's no way to know. But here's what you can check. Does your life feel unusual? Not in the I'm special way everyone feels, but genuinely statistically weird. Do impossible things keep happening to you, both good and bad? Do you find yourself in situations that seem absurdly unlikely? If your life has been remarkably smooth, remarkably uneventful, statistically boring, you're probably in a high probability timeline, a normal branch. But if your life has been extreme, either extremely lucky or extremely unlucky but you keep surviving, you might be in a tail-end timeline. A rare branch, one of the few where you're still alive despite everything. And here's the deeply unsettling part. You can't know. There's no control group, no way to compare your timeline to the ones where you died. You only have this one data point, this one life, this one experience. Maybe you're typical, maybe you're not. Maybe you died yesterday in a quantum fluctuation, and your consciousness is now experiencing a branch where you didn't. Maybe you've been dying and resurrecting at the quantum level every second of your life. You'd never know. All you can do is notice, pay attention, ask the question, is my life statistically normal, or am I living in an increasingly improbable timeline? There's no answer, just the question, and the fact that you're here to ask it. Let's examine whether any of this can be proven. Let's be honest, quantum immortality might be completely wrong, and we need to confront that. Because if we're doing this investigation properly, we have to look at where the argument breaks down, where the logic fails, where physics and philosophy part ways. First problem, the many worlds interpretation itself isn't settled science. It's one interpretation of quantum mechanics among several. Copenhagen interpretation says the wave function actually collapses. There's no splitting. Pilot wave theory says particles have definite positions all along. Quantum Bayesianism says the wave function is just information, not physical reality. Many worlds solve certain problems elegantly, but it creates others. Like the measure problem, how do we assign probabilities in a universe where everything happens? If all outcomes occur, why do we experience some outcomes more frequently than others? Physicists don't have a good answer, which means the foundation quantum immortality is built on is uncertain. Second problem, does consciousness actually transfer between branches? The many worlds interpretation says the universe splits. But does your subjective experience, your sense of being you, somehow follow a particular branch? Why that branch and not others? There's no mechanism for this. No physics that explains how consciousness selects or experiences one branch over another. It's assumed, not derived. Maybe when the universe splits, both versions of you are equally conscious, both are you, in which case you do experience dying in half the branches. Your subjective experience doesn't avoid death, it includes death. You just can't remember it because the dead versions can't report back. Third problem, what counts as you? If a quantum event in your brain changes slightly, creating two nearly identical versions, are they both you? What about versions that diverge more significantly? At what point does a branch version stop being you and start being someone else? Personal identity is already philosophically murky. Quantum branching makes it worse. Fourth problem, consciousness might require certain minimal conditions, a functioning brain with sufficient coherence and integration. Below that threshold, you're not conscious. You can't experience anything. If that threshold exists, then when your body fails sufficiently, all branches converge. You die in all of them. There's no survival branch because there's no conscious you to experience it. Quantum immortality assumes consciousness can persist in any branch where you're technically alive. But alive and conscious might not be the same thing. Fifth problem, the preferred basis problem. When does the universe split? At what level of description? Quantum mechanics doesn't specify. The math works the same whether you think of splits happening at particle interactions or larger scales. If splits happen at every quantum interaction, the branching is effectively continuous and consciousness can't coherently track it. If splits happen at some higher level, we don't know what determines that level. Most physicists who accept many worlds don't take quantum immortality seriously. They see it as a thought experiment that exposes problems in our understanding, not a genuine prediction. Max Tegmark himself, who proposed quantum suicide, doesn't claim quantum immortality is definitely real. He presents it as a logical consequence if certain assumptions hold, but those assumptions might not hold. The honest answer is, we don't know. We don't know if many worlds is correct. We don't know if consciousness works the way quantum immortality requires. We don't know if subjective experience can avoid death or if death is simply unobservable from within. This might all be wrong, but it might not be. And that uncertainty, that's what we have to live with. Let's talk about what it means if it's true. So let's assume it's true. Let's say quantum immortality is real. You can never experience your own death. From your perspective, you continue forever. What does that change? Everything or nothing? Start with the obvious. If you can't die, does anything matter? Traditional meaning often comes from scarcity. Life matters because it's finite. Moments matter because they're limited. We treasure experiences because we won't have infinite chances to have them. But if you're subjectively immortal, that scarcity disappears. You'll always have another moment, another chance, another lifetime effectively, because you'll keep surviving in increasingly improbable branches. Does that make everything meaningless? Or does it free you to find meaning elsewhere? Some would say meaningless. If there's no end, there's no urgency, no stakes. You can procrastinate forever because forever is literally what you have. Every mistake can be survived. Every opportunity missed will come around again in some form. Others would say liberating. You're free from the tyranny of death, free to take risks because you'll survive them, free to explore, to experiment, to live without the constant shadow of mortality. But there's a darker reading. If you can never die, you can never escape. You're trapped in existence, condemned to experience consciousness forever, in bodies that decay, in timelines that get stranger, in a life you can never opt out of. That's not freedom. That's a prison. And then there's the ethics problem. If quantum immortality is real, should you be more reckless or more careful? More reckless because you'll survive anyway? From your perspective, you always do. So why not take wild risks? This is the quantum suicide problem taken to its logical conclusion, and it's deeply dangerous. Because while you might subjectively survive, you're creating branches where you're horribly injured, disabled, suffering. You can't experience death, but you can experience agony, and other people die in the branches you create. If you drive recklessly and cause an accident, you might survive from your perspective, but the person you hit doesn't. They die. In your timeline, you killed them. Quantum immortality doesn't make you invulnerable. It makes you unkillable from your own perspective. There's a difference. So maybe you should be more careful, because even though you can't experience your death, you can experience everything leading up to the threshold. The pain, the injury, the degradation, and you're responsible for the harm you cause to others who aren't protected by the same subjective immortality from your actions. Then there's the question of free will. If the universe branches at every quantum event, do your choices matter? All choices happen in some branch. You choose to quit your job in one branch. You choose to stay in another. Both use exist. Does that mean choice is meaningless? No, because you still experience one branch. Your choices determine which branch you experience. They still shape your subjective reality, even if other versions of you make different choices. Maybe that's the answer to meaning. Not that quantum immortality makes life meaningless, but that it clarifies where meaning actually lives. Meaning isn't in the objective fact of existence, it's in subjective experience, in what it feels like to be you, moment to moment, in the choices you make and the experiences you have. And if quantum immortality is real, you'll be having experiences forever. The question becomes, what kind of experiences do you want to have? Let's talk about whether it even matters if we can never know. We've followed the logic, traced the implications, confronted the horror and the uncertainty, and we're exactly where we started. We don't know. You can't prove you're quantum immortal. You can't prove you're not. The evidence is your continued existence, which is also the null hypothesis. You're alive. You've always been alive from your perspective. That's not data, that's just being. Every near miss could be quantum immortality in action, or it could be luck. Every survival could be evidence you're in a low probability branch, or it could be normal probability playing out normally. There's no experiment you can run, no measurement you can take, no way to peek outside your own subjective experience and see the other branches where you died. You're inside the question, and the question has no answer. But maybe that's the point. Maybe consciousness is always uncertainty, always questioning, always experiencing from the inside without access to the outside view. You're conscious. You don't know if you're quantum immortal. You know you're alive. You don't know if you're in a typical timeline or an improbable one, and you'll never know, not with certainty. The investigation can't be completed, not from inside, Not with the tools we have, maybe not ever, but we investigate anyway, because that's what conscious things do. We ask questions we might not be able to answer. We probe mysteries that might not have solutions. We wonder. And quantum immortality, if nothing else, gives us something profound to wonder about. It forces us to confront what we mean by existence, by death, by probability and experience, and the difference between objective reality and subjective perspective. It makes us question whether we're living a normal life or an impossible one. And maybe, just maybe, it makes us pay attention to the near misses, to the moments we're still here, to the improbable fact of consciousness continuing moment after moment in a universe that seems indifferent to whether we exist or not. You're alive right now, reading this, thinking about this, experiencing this moment. That's not nothing. Whether it's typical or improbable, whether you're in base reality or one of billions of branches, whether you'll continue forever or end tomorrow, right now, you're here, conscious, aware, wondering, and from your perspective, you always will be, until you're not, and you won't experience the transition. So this moment, this investigation, this wondering, this experience of being alive and conscious and uncertain, this is all you have. All you can ever have. The quantum immortality paradox can't be solved, but it can be lived with, acknowledged, integrated into how you understand your existence. You might have died 1,000 times already, you might die tonight, or you might continue experiencing in increasingly strange timelines for subjective eternity. You'll never know which. All you can do is be here, now, paying attention to the mystery of your continued existence, and maybe that's enough. If you've stayed with us through this investigation, if you've sat with the uncertainty, confronted the implications, questioned your own existence, we're grateful. These are deep waters, strange territories, questions that might not have answers, but they're worth asking, worth exploring, worth wondering about. We'll continue investigating the deepest mysteries consciousness can encounter, the questions that reach all the way down, the paradoxes that live at the intersection of physics and philosophy and lived experience. If that resonates with you, we'd be honored to have you subscribe. More explorations, more mysteries, more questions that change how you see reality. But whether you're here for one night or many, thank you for wondering with us. You're alive to wonder, however improbable that is, however long it lasts. And in this moment, in this branch, in timeline, that's real, that's enough.